Welcome back, guys. So today we're going to continue studying how to solve quadratic equations. Today we're going to look at quadratic equations that are in the form of ax squared plus bx plus c, where a is 1. Okay, here, for example, we have the difference of two squares. Remember, x squared is a square root and 25 is a square root, or a perfect square. Okay, and so we're going to look at how to solve this type of equation. The first thing I want to introduce to you is the zero product property, which says that if I take two numbers and I multiply them together and I get that my product is 0, then either one of the numbers has to be 0. Either a has to be 0 or b has to be 0. Okay, and so we're going to be utilizing this property a lot when we solve these types of quadratic equations. Now, what I want to also mention to you is, for example, let's take this example x, our difference of two squares, x squared minus 25. Remember, to factor this, that we take the square root of x squared, which is x, and we take the square root of 25, which is 5. And these become our factors, and so we end up with two binomials with different operations, one of which is x minus 5 and the other which is x plus 5. Okay, now when we are trying to solve an equation, remember, an equation is where we have a variable and maybe a constant equal to some other variable and constant on the right hand side. When we're solving an equation that involves quadratics, we are no longer looking for a pair, the product of two binomials. Now we're looking for specific values of x that make this equation or this statement true. Okay, we're going to use the same techniques as we did before. We want to factor the quadratic first. And so we've already factored it earlier, which was x minus 5 times x plus 5. And that's equal to 0. And so now what we want to do is we want to use our zero product property that says if x minus 5 times x plus 5 is equal to 0, then that means that either x minus 5 has to be equal to 0 or x plus 5 has to be equal to 0. And now we have two linear equations that we can solve. Okay, and so we're going to add 5 to both sides. That equals should not be there, sorry. Okay, we're going to add 5 to both sides, and so this cancels and we get that x is 5, or if we subtract 5 on this for this equation, we get that x is negative 5. So whenever we're solving quadratic equations, we expect two solutions. And we can write that in set notation, which would be our curly brackets. And you always put the negative first, the negative solution first. So negative 5, 5 in curly brackets, and this is our solution. Okay, let's look at another example. Now we have x squared plus 10x equals negative 21. So here, we want to solve this, this quadratic equation. But the first thing we must do, and the first thing you must do in all quadratic equations, is you must make sure that your right-hand side is 0. Okay? So we must do a little manipulating first to make sure that this right-hand side is 0. So what I'm going to do is in order to get this 0, we need to do the additive inverse. So I'm going to add 21 to both sides of my equation. When I do that, I get x squared plus 10x plus 21 equal to 0. Remember, I cannot add 10x and 21 or x squared and 21 because none of these are like terms. Okay, and so now I want to factor my my quadratic, and so if you need to review this, do so. So we get, when we factor, we get x plus 7 and x plus 3. And now again, using my zero product property, I have that either x plus 7 has to be 0 or x plus 3 has to be 0. And if I solve these two, I get x is negative 7 and x is -3. Okay, and again, I want to write this in set notation. So I'm going to use my squiggly brackets. -7 is less than -3. So I'm going to put -7 first, close squiggly brackets, and this is my solution. Okay, one last example. So I have the height of a cliff diver above the water during a dive is found by the function h equal to -16t squared plus 16t plus 96. Okay, and I want to find out how long the diver is in the air. So imagine we have this cliff. This is our cliff. And this diver jumps off the cliff. And we want to find out how long he was in the air. So we have our function -16t squared plus 16t plus 96, and we want to find out that's equal to h, and we want to find out how long he was in the air. So the time he was in the air would be between the time that he jumped off the cliff, so this position, and the time he hits the he lands wherever he lands, if it's water or if he's as such. Okay, so remember these two distances, they're the initial distance. So what we want to do, we want to make h 0, and that will give us the time that he was, the amount of time he was in the air. Okay, and so again, I want to factor. I'm going to pull out a -16 because I want to keep my beginning coefficient positive. And so this is t squared minus t, and then minus, I need a positive, so -6 equal to 0. Now, here, this means that either, here we have a times b, so this means that now I want to factor. So -16, this is going to be t, and I need a -1 in the middle, so I'm going to have 3 and 2, and I need negative, positive. Okay, so here we have three things that we need to look at. Either 0 can be equal to -16, t minus 3 is equal to 0, or t plus 2 is equal to 0. Now, we know that -16 can never be equal to 0, so we can just automatically cross that out. Now we're going to solve our two linear equations. So we're going to add 3 to both sides, and so we get t equals 3, and subtract 2, we get t equals -2. Now here, because of the context of our problem, we know that we can never have a negative time. He can never be in the air for -2 seconds, right? So we can automatically disregard this solution. And so we know that he was in the air for three, I guess, seconds. This would be, I believe our unit of time was seconds. The height, how long is the diver? So I'm gonna say seconds. Okay? All right, and that is the end of today's lesson.